All right, let's talk about the intuition behind the proof of the integration of cosecant x. So the proof of the integration of cosecant x, what we want to do here is we actually multiply the top and the bottom of cosecant x by cosecant x plus cotangent x. And what this does is allows me to take the denominator, and when I take the derivative of the denominator, I actually end up getting the numerator. And this allows me to replace the numerator with negative du, and then we do the standard integration and u sub back in what we said u was. So the question emerges, which is, how was this thought of? How would you be able to see some of this? And developing skills in this intuition allows us to uh, help yourself if you're taking a class like Cal 2 and you forget. Um, it gives you sort of a way of kind of remembering what the integration of cosecant is. And if you're in future courses, if you have to do any sort of proof-based course, it gives you a little bit of insight as to what are some things I might want to try to do in order to solve this set problem. So what's important to realize here is that the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. And why is that important? Well, if you take the derivative of this and this, what you're going to end up getting, right, is essentially the same thing. What is this really? If we factor out a negative cosecant x, you're left with cotangent x plus cosecant x, which is what is here. So the intuition behind it was the ability to see that if I took the derivative of this, I would arrive at this because of the fact that if you distribute cosecant x into cotangent and into cosecant, you get back there. And so the idea is when you get stuck, we play around, right? So if you took this, and I think what was most intuitive to most people is to rewrite it as the integration of 1 over sine x, but you can't do u sub with sine because you're going to get cosine, and there's no cosine in the problem. And the rabbit hole to creating that is not worth going down. So what do you do? Well, one insight is to think about, well, what are my derivatives, right? We know what we get when we take the derivative of cotangent. We know what we get when we take the derivative of cosecant. And then noticing that they both share something in common, in this case cosecant, and if you factor that out, that gives you the tool to find the derivative. So just a little insight, just a little bit of a way of thinking that maybe provides insight in future situations that will help you solve sophisticated math problems. So hopefully this gave you some value. If you have some comments, feel free to share them with me, and I'll find you in the next math video.